What's good, everybody? It's your host, Joe Caffarelli, coming at you with another episode of Hacking This World, baby. All right, we're going to jump right into TryHackMe. We're going to continue on where we left off. Now, I think it's been about a week. Since I've been off my training, my hackery training. It's been a very busy week here. So, all right, let's get into it. Where we left off the last time we were on the platform, we had completed the Linux Fundamental Part 1. Now let's get into the Linux Fundamental Part 2. All right. Before we get started into everything, guys, make sure you guys like, share, and subscribe to all my social media platforms out there. Especially on, make sure you guys are subscribing to YouTube, subscribing and following and doing whatever on the Twitch, and doing the same thing over at the Rumble, guys. I could really use it. It's free. You just press the subscribe button, guys. That's it. All right, let's get into it. All right. Let me do a quick audio check on everything. It's because the music on my last stream, I had the music up a little too high and kind of overdid it was overdoing my voice. I also moved my microphone too, as you can see. It's a little bit closer now too, so hopefully you guys can hear me better now. Let me just see what's cracking in here. All right, let me just do an audio test. 1, 2, 3. Yeah, it should be okay now. Just listen to it for a second. Music's pretty low too. I like that. Sure, it does pick up everything. That's the only problem I have with the mic. It picks up absolutely everything right there. That should be fine. It should be okay. It sounds okay. Guess if it doesn't sound okay, you guys just tell me. All right. Good enough. Good enough for me. All right, let's get into it, y'all. It's my beautiful hair. All right. Part 2 here. All right. Welcome to the second part of the. Let me close my window. It's going to be hot as heck in here. I'll bring some of that noise down. Bring some of that traffic noise down a little bit. All right. Welcome to the second part of the Reworks Linux Fundamentals series. We will be applying our knowledge from the first installment in this series, so I highly recommend you completing that room before proceeding further. In part 2, we'll be ditching the in-browser functionality and help you get started in what is the fundamental skill of being able to log in to control the terminal of a remote machine. Not only this, but this room will also have you unlock the potential of your first few commands by introducing you to using flags and arguments. I like it. Advancing your knowledge of the file system, perform some more useful commands such as copying and moving files, introducing you to the access mechanisms to keep files and folders secure, and how to identify these things on your current user has access to. Running your first few scripts. All right. Well, let's get into it, y'all. All right. The in-browser functionality was used in the Linux Fundamental Part 1 to get you directly to connect to your first ever Linux machine without any hassle. In fact, the in-browser functionality uses the exact same protocols that we are going to be using today. The protocol called SSH, or Secure Shell, or SSH for short. It is the common means of connecting to and interacting with the command line on your remote Linux machine. We will be deploying 2 machines in this room, your Linux machines and the TryHackMe HacktheBox. What is SSH and how do we use it? Secure Shell SSH is simply a protocol between devices is in encrypted form. Simply a protocol between devices is in encrypted form. Okay, spelled wrong, but whatever. Using cryptography, any input we send in human readable format is encrypted from traveling over the network. Where it is then unencrypted once it reaches the remote machine, such as the diagram below. So we have our little encryption here, our little SHA, micrometer, Linux server. You can learn about the various types of encryptions on the TryHackMe rooms, but for now, we'll only need to understand the SSH allows us to remotely execute commands on another device remotely. Any data sent between the devices is encrypted when it is sent over the network, such as the internet. Okay. Deploying your Linux machine. Press the green start button at the top right of the screen. Deploying the TryHackMe. Alright. Start the machine. The attack box. This is your attack box. Usually the attack machine it's just started. This machine you have just started that we practice hacking on. So we're getting our now. Let me see. So we've been using HacktheBox to. I want to see how this is similar or different in its comparison to what we're going to be doing here. So we've got our active machine. It hasn't come up yet. It shows IP address. So okay, it's still everything's pretty much loading up right now. Okay, so we have an IP address now. Coffee is strong today with this one. All right, I'll let that boot up real quick. All right, first for this room. Okay, using SSH to log into your Linux machine. The syntax to use SSH is very simple. We only need to provide 2 things: the IP address of the remote machine and correct credentials to a valid account to log in with our remote machine. From this room, we'll be logging into the TryHackMe, whose password is TryHackMe. Without obviously the quotation marks, let us use the IP address of the machine displayed in the card at the top of the room as the IP address and at the top of the room as the IP address in this user to construct a command to log into the remote machine using SSH. The command to do so is SSH, and then a username of the account followed by the @ sign. The @ sign. I don't know if it's the @ sign. All right. But first, we need to open a terminal to the TryHackMe. Let's open the terminal real quick. And here's an example of our command. So let's go back to this. We'll copy that. So we're going to do SSH to doesn't like control. Is there no clipboard between these? No clipboard. Come on, TryHackMe. It's messed up. I can probably handle that thing. All right, so we're inside the TryHackMe computer there. And we have some folders. We have important, my file, my folder, and unknown. We have 3 files and then a folder, so we can so I'm guessing that's a flag maybe. My file system, and then we'll look up the other one, and then we'll go into the folder maybe. Hello from TryHackMe. There's nothing in this folder. All right. So we have, looks like we've got a couple flags here. We've got a user flag, we've got a system flag right here. All right, but first we need to open a terminal, which we did. Terminal from the, for an example, yeah, and that's what we did. So we successfully logged the SSH, we successfully SSH'd into our victim machine. Now that we are connected, any commands that we execute will now be executed on the remote machine, not our own. When you type a password in the SSH, so it's just saying that when you type in a password inside of like a Linux terminal prompt, for the most part, you're not going to see any of the any visible feedback from what you're typing in. That is that's a security. That's a security feature, so in case somebody's actually looking over your shoulder, they can't see how long your password is and stuff like that, even if it's blotted out and stuff like that with like the multiply sign or whatever else. All right, I've logged into the Linux fundamental using SSH. Yes, we have. Okay. Introduction to flags and switches. The majority of commands allows for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as a flag or switch. So this is where we're going to get into learning flags and switches. Arguments, more arguments. We'll later discuss how we can identify what commands allow for arguments that to be provided with understanding of what these exactly do. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls list the contents of the working directory. However, hidden files are not shown. We can use a flag in switches to extend the behaviors of this command. Using our ls, example ls, informs us of the folder name. Informs that we only have one folder name, folder 1. It's highlighted in the screenshot below. Where's it again? Oh, this is just an example. And it's just showing us flags. So I know there is a ls. So if you do ls ALS, so you have A that stands for all. I'll just do the less help. So the A switch or A flag, whatever you want. Do not ignore entries when started with the period. So when files start with a period, they're hidden files. Okay, and then the L. So the lowercase L's, using long listed formats. So long listed format, you don't always have to do that, but if you're looking for like when something was modified, when a file was modified or a folder was modified or something like that, you can use the long format and it'll give you dates on modifications and stuff like that. And then the S size, print the size of each file and its block size and stuff like that. So there is that ls minus A is one of the more useful ones. So you can see that what we have a couple hidden files here. So we have the bash logout, the bash RC. Bash RC is you can create your own like alias file. going through the bash RC. It's just the bash RC. I won't get to that. But the bash RC file is pretty neat. Pretty neat file. Yeah, I can just show you real quick. That was like nice. So in here, this is where you can change. You can change like how your name looks and stuff like that on the terminal, how that gets put out. Also colors too. You can change up how you do colors. There's some aliases. Yeah, so there's some aliases that you can get started off with right here. It asks you to create your own alias file and stuff like that. That's neither here or there. I just wanted to get into that because I love this one. All right, let's continue on here. So this is just showing an example of the ls or just the help flag. I want to say most all Linux commands have a help flag. They also have man pages. Yeah, and I want to say they all have man pages too. There is extended man pages that say if a developer, they'll create a man page, but then they'll want you to redirect that to a web page, stuff like that. So this is just going over the man page. We can do ls man and to pull up the manual. So it gives you pretty much all the information you're going to want to know about a particular command. So on this one, name, ls, list directory contents, description, list information about the files in the current directory by default, sort entries alphabetically if none of the flags or the sort is specified. Mandatory arguments, too long option are mandatory for shorts too. So again, it just gives you it like the help when like developers they'll take like a small part. They'll take usually all the flags will be taken out of the man page and put into like that little help thing. But you'll get some of the same information. But then it gets to the more specific information like the author, how to report bugs, copyright information, and then again, like I said, so you can always find. There's usually more ways to find more documentation of commands and stuff like that. It'll redirect you to a web page in most cases. All right. Explore the man page of the ls with that. What directional arrow keys would you use to navigate up and down the man page? What directions would you use to navigate up and down? Is that nice? I'm gonna say down. The down arrow key. Ooh, I was right on that. What flag would we use to display the output of human readable way? So we go back here. Human readable, so we would use the H switch, H flag, which is with LNS prints. So let's just check out how that would look. It doesn't really do anything special, but it's what it is. That's the flag. the switch we're looking for. All right. All right. We covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, we've covered how to list and find contents of folders using ls and find, and navigating the file system using cd. In this next text, we're going to learn some of the more commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders. More specifically, the following commands. So we have touch, make directory, cp, copy, and the move rm, remove file. So I guess touch is the only one that just has a weird name. It's always been that, like touch. But that's what creates a file. Make dir, create a folder. Copy, cp, copy a folder. Move rm. So yeah, so those are just some of the more basic, some of the more fundamental basic commands when dealing with files and folders through the Linux terminal. Creating files and folders, touch and make dir. Creating files and folders on Linux is a simple process. First, we'll cover creating a file. The touch command takes exactly one argument, the name we want to give the file we created. For example, if we want to create a file note by using the touch note, it's worth noting that the touch simply creates a blank file. You would need to use an argument like echo or text editors such as nano to add contents to the blank file. Let's see. This is a similar process for making a folder, involves using the make dir command, again providing the name of the name that we want to assign to the directories. For example, creating the directory, my directory, using the make dir my directory command. Rm, removing files and folders. Rm is externally out of the commands that we've covered so far. We can simply remove files by using the rm. However, we need to provide the reclusive, the uppercase R flag, switch alongside the name of the directory you wish to remove. So if you want to remove a directory, you have to add that flag in. And we can take a look at that. So if you do rm help, the double doubles. Excuse me. So this is where we have the R flag. So we have the reclusive flag, removes directories and their contents reclusively. Okay, so that's what we're looking for when we're removing a folder. All right, copying and moving folders with cp or move. Copying and moving folders is an important function of the Linux machine. Starting with cp, this command takes two arguments: the name of the existing file, the name where we wish to assign the new file when copying. cp copies the entry contents of the file existing into a new file. In the screenshot below, we've copied note to note 2. So you can see that it simply takes in. So we come over here and touch note. Let's do this. Let's make this interesting. Echo. I always spell world wrong. I don't know why. How did I do that? Oh, because Echo created the file. That's funny. Let me do that again. I didn't realize what I did right there. Oh, let me do it this way. Touch, node, txt, and then there it goes. that didn't work. I didn't miss it. All right, but we'll remove a couple of these files real quick. So we have our note file. We'll remove that, and then we'll remove our touch file. And you can see it goes back to everything's normal. Oh, we have a halt low. We're up. Let me just remove those real quick. There we go. I have an echo. Really, I messed this one up, didn't I? There we go. Back to normal again. There we go. I was trying to do some redirecting, but I must be forgetting how to redirect everything. So what happens when you get rusty? But let's just make a folder so we can do a make dir, and we'll say dir1. All right, and then if we try to remove dir1 without the flag, cannot remove dir1. It is a directory, so again we have to use the reclusive flag there. And then as we can see, we removed our directory there using our flag. But then if we want to copy a file, so we can just make a file real quick. So we'll say touch note. That's where I messed up. I think so, yeah. Okay. Now let's do echo hello world. Change the output to touch. Oh, messed that one up. My redirecting is all messed up today. I don't know what I'm doing wrong. I thought it was redirect. Yeah, I'm gonna. Okay, let me just make a file real quick. And we can copy it. So as you can see, we have our note 1, and then we can do a CP note. Note 2. We have a note 2, and then if we want to move note 2 to, what's that, my folder. As we can see, our note 2 is gone. If we go look in my folder, we can see that our note 2 is there. Alright, so copy, removed, determining file type. What is often misleading and often catches people out is making presumptions from files as what their purpose or contents may be. Files usually have what's known as an extension to make this easier. For example, text files usually have an extension of .txt. But this is not necessary. So far, the files we have used in this example haven't had any extensions, but knowing the contents of why the file is there, we don't really know its purpose. Enter the file command. This command takes one argument from the example we used file to confirm whether or not note file in this example is a text file. So it just tells you, gives you information of the file type. There we go. So if we do file note, because there's nothing. So if we go to go. So it just tells you note, and then there's some text. So the ASCII2 text. So it's just saying there's text in the actual file there. All right. How would you create a file named new note? On the deployable machines, what is the file type of unknown in the TryHackMe directory? So if you do file, and what we get back is the, let's just ask you to text. I don't know if that stands for Roman numerals or not. We're gonna see. I guess it does. How would you move a file, my file, to directly my folder? What is the contents of this file? What is the contents of this file? This is my file, I'm gonna guess. So file 16. All right. Continue to apply your knowledge and practice. Yep. Okay. It's done. We're moving right along here, everybody. Ah, coffee's cold. Ah. Hold on. I need coffee. I just need to warm it up. I got a whole pot. Let me go grab some coffee real quick. I'll be right back. Coffee, 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 coffee. Coffee. Coffee, 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 coffee. Everybody loves coffee. Alright. My hair is falling out, guys. Someone had no more hair. That's why I'm letting it all grow up. Alright. Alright. As we have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads us. In our previous tasks, we've learned how to extend the use of commands to flags and switches. Take, for example, the ls command, which lists contents in the current directory. When using the -L switch, we can see 10 columns, such as in the screenshot. However, we're only interested in the first 3 columns. So that's where it's showing you. So the long format here. So you can see where you have permission. So this is the permissions. This is the ownerships. Obviously, creation, block size, creation date, and then name. columns. Although intimidating, these read columns are very important to determine certain characteristics of a file or folder, and whether or not you have access to it. A file and folder cannot have a couple. A file and folder can have a couple of characteristics that determine both what actions are allowed in what user groups has the ability to perform given actions, such as the following: read, write, and executable. So this is where this section right here, where it displays some of the permissions that these files and folders have. So you read, write, read, and so it's going to get in. It's most likely going to get into permissions and how to go about that. So I won't go about it. I won't get into too much of my bad explanations about it. Using the SU to switch to user 2. Let's use the cinematic perm file in our initial screenshot at the top of this task. It has the this file file F. This means that not only the owner of the file can read it and write for it. This cinematic perm file but cannot be executed. What does this mean? What is this thing getting into here? Is it just talking about, yeah, it's just going off on its own little tangent here. No, it's just talking about this file. All right. Briefly, the difference between users and groups. We briefly explored this in the Linux Fundamental Part 1, namely the difference between a regular user and a system user. The great thing about Linux is that permissions can be so granular that that with a user's technically owns a file if the permission has been set. Then a group of users can also either have the same or different set of permissions to that exact same file without affecting the file owner itself. Let's put this into a real world context. The system user that runs a web server must have permissions to read and write files for the effective web application. However, companies such as a web hosting company will have to want to allow their customers to upload their own files to their website without being the web server system administrator, compromising the security for every of their customers. We'll learn the commands such as necessary to switch between users below. That was a little bit of a confusing sentence right there. I don't know why. It left me confused. So switching between users. Switching between users on a Linux system, switching between users on a Linux installed. What? It's easy work thanks to the SU command. Unless you are the root user or using root permissions through sudo, then you are required to know two things to facilitate the transitions of users' account: the user we wish to switch to, and the user's password. The SU takes a couple of switches that may be of relevance to you. For example, executing a command once you've logged in, or specific shell use. I encourage you to read the SU man page to find out more. However, I'll cover the L switch or the login switch. Simply by providing the L switch to the SU command, we'll start the shell that is much more similar to the actual user login to the system. We inherit a lot more properties of the new user, i.e. environmental variables like this. For example, when using the SU switch to users 2, our new session drops us into a previous. Okay, so what is we're now, after using the -L, our session has dropped us into the home directory of the users. Okay, so what it's saying is so if we use the su command by itself to log in as a user, we will remain in the same directory that we're currently in. But if we use the -L flag, it will prompt us over to the home directory of that user. So if we do this here, we've got user 2. It's a bad password. Probably a bad password. Okay, so 216. There we go. So as you can see, we're in the exact same directory, okay, that we were just in. It hasn't switched directories. Now if we I can't even spell. So if we exit and then we log in again, su user 2, and then we use the L flag, L switch. Okay. Now you can see that we're in the home directory of user 2 now. Okay, so we moved out of the directory, the user TryHackMe, and we've moved into the home directory of user 2 here. That's my mic. All right, let's exit out of that. And now we're prompted right back to where we were. As we can see, we're back in that same directory. Actually, let's do this. pwd TryHackMe. So you have home TryHackMe, and we'll do. See. And then you can see. So we have the home for TryHackMe, and then the home for user 2 right here. So that's how you again. You can tell what the pwd. Let's look up that. I can do like this. All right, print name of current working directory. pwd, print name of current working directory. There you go. Spell. All right, on the deployed machine, who is the owner of important? So again, we use the L for the long format here, and we're looking for the important file here, and the owner is user 2. What would be the command to switch the user to user 2? So we have the su user 2. Now switch the user 2 using the password. Yep, do that. I'll put in the contents of the important. So just come over here. And then we have GHM, TryHackMe, su user 2. Very good, very good. Times about 20 minutes left. I gotta go grab the kiddos off the bus. We're doing pretty good. All right, common directories. This root directory is one of the most important root directories on a system. The Etsy folder, short for Excentra. I have never. Excentra or Excentra. Ooh, I can't even pronounce that right. Excentra. I guess it's Excentra. Am I saying that right? I just call it Etsy. Etsy. The Etsy folder is a commonplace location to store system files that will be used by your operating system. For example, the sudo The sudoer file highlighted in the screenshot below contains a list of user groups that have permission to run sudo or a set of commands as the root user. Also highlighted below are the password and shadow files. These two files are special for Linux as they are shown how your system stores the passwords for each user's in an encrypted format called SHA-512. Okay, so the passwd and the shadow files are two special files on the Linux machines that stores passwords for each user's in the encrypted format with the SHA-512 format. Okay. And I guess we do. So there's shadow and PWD. And PWD. So if we do a cat on shadow, not even that, but it's still okay. Yeah, you won't even let us cat it out or cat. Won't even let us open it with it. So then we have the var directory. Var directory, with var being short for variable data, is one of the main root folders found in Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, the log files for running services and applications are written to the var log. Other data that is not necessarily associated with specific users, database, and so on. All right. So if we go to, we just have those here. So there's what's in our var directory: backups, caches, local logs, opt, temporary caches, just a couple of things in www. Just a couple of variables variable folders that are in there. I am so I gotta get this AC in there. Two things. It'll cut down on the outside noise. Cut down on that outside noise that I have, and it won't make it such a squatcher in this room. It's a squatcher. What is it today? What is it today? 77. This guy, I love the guy next door, but he's always blowing his yard. Every day. Blows his parking lot. Every day. Cleanest parking lot I've ever seen. Eat off of it. And there he is. You guys can probably hear him right now. Below it. See, when I use OBS, instead of this, has, I guess, more power in how I could cancel out background noises with the mic and stuff like that. But on this platform, it doesn't do a great job at canceling out background noises. But it is what it is. Hopefully it's not too distracting. I'm getting distracted. All right. Unlike the home directory, the root folder is exactly the home of the root system user. This isn't anything more. To this folder other than just understanding that this is the home directory for the root user. But it's worth a mentioning as a logical assumption is that the user would have their data in the directory such as /home root by default. TMP folder. This is a unique root directory folder found on Linux installs, short for temporary. The temp directory is volatile and is used to store data that is only needed to be accessed once or twice, similar to the memory on the computer. Once the computer is restarted, the contents in its folders are cleared out. What's useful for us as pen testers is that users can write to this folder by default meaning once you have access to a machine, it serves as a good place to store things like immersionary. That's the word I always hate saying. Immersion. I see my speech impediment. It still bothers me to this day. There's still words that I cannot pronunciate for the life of me. So if we take a look at the and it just has some Bugattis in it. All right, so cloud init, probably just from it being spun up and stuff like that. All right, read me. I read me. Okay, what is the directory path to that would that you would expect to see? So that'd be our logs, so log. What root directory is similar to RAM? So that's /temp. What is the name? Yep, /root. Now apply your learn to navigate through the. We've been doing a great job at that. All right, conclusions and summaries. Nice work. This room was quite theory heavy and covered quite a range of fundamentals in getting you familiar with Linux. To do a quick recap, this room taught you how to connect to a Linux machine remotely using SSH, advancing your use of commands by providing flag switches, and where you can go to learn about these for each command pages. Some more commands that you'll use frequently by using to interact with the file system, the content. We've done that. A brief introductions to file permissions and switching users. A summary paragraph of the important root directories of the Linux install and how we may be able to use data stored within these. I encourage you to go throughout this room once or twice to gain familiarity with concepts. After all, practice makes perfect. Alright. Terminate the machines from task 2. Okay, so let's shut down everything. Okay, look at that. Woo! All right. I got it. All right. Part 3 now. How's everybody doing? Hope everybody's doing good. All right. Welcome to part 3 and the final of the Linux Fundamentals module. So far throughout the series, you've gotten your hands on with some fundamental concepts and used some important commands. This room is going to showcase some useful utilities and applications that you are likely to use day to day. You're also going to advance your Linux foo skills. Linux foo, what? By learning about automation, package management, and service application plugin. I've got to do something about that. I'm just probably awful. You guys can probably hear it a lot. Let me just check it out. Nah, you can't hear it too bad. Music's loud though. Not that bad. Nah, the music's not that loud. If the music is too loud, guys, just ask me to turn it down, okay? Okay. You can't hear it too bad. That's pretty good. I'm happy with that. I'll accept that. Alright, so let's get this machine started. Start the TryHackBox. So we're gonna get our IP address in a little bit. Username TryHackMe, password TryHackMe. There we go. So we have some of our credentials already there. Woo! Ooh, it's a scorcher today. It's only 77 and I'm burning up in here. I gotta get the AC set up. Me and the wife have been trying to put it off to the very last minute because I don't know if we're gonna be able to afford the electricity payments this month. I've already had to kill my server. My server's been off for the last month now. I just could not afford to run it anymore. Look at that, it even populated the IP address for us. That is cool. There it is. Just give it a second for our hack box to finish loading up here. So, how's everybody doing? Hope everybody's having a good day out there. Staying healthy and yeah, learning. Everybody should be learning every day. Yeah, simple things like that. I think later on today, I got a little bit of schoolwork to do, but I think shortly after this, I'll probably, I haven't played any video games in a while, and I downloaded Fallout New Vegas the other day. I played that game about halfway through. I did like a halfway walkthrough on that one before. It's fun. I like New Vegas. It was an interesting story, New Vegas. I did play. I destroyed Fallout 4. I played every DLC. That game was super fun. But I want to get back into New Vegas. It's been a while. I don't remember everything. So, all right, let's SSH over to TryHackMe. Inbox here. Password. I don't know. That's what that is. No, don't know I spelled it wrong. I spelled it wrong again. I guess I did spell it wrong. Oh. TryHackMe hack. That's funny. Does that exist? It did exist. Oh, no. There is no user by that name. Man, I am out of my mind. Wonder why that did not work. 10.10.172.219. Hey, that's what. No, it's not because I spelled it wrong. What is wrong with me today? Tired or something? Sorry, just sweating all my intelligence out of my head. There we go. There we go. selected editor. Ooh. So we have a couple. So we have inside of the we did the ls with the -all flag. Located a couple of extra files. So we have a flag text file, a profile, a selected editor. So some of these things were hidden from our view. So if we look here, we just see task 3. Let's do a cat on task 3, see what it actually comes up with. And we have a little flag right here. But then we can do a cat on what is it, flag, and we have another flag right there too as well. So I want to see what selected editor is. So it could just be, yeah. So it's just generated by user bin select editor, and then the select editor. It's just setting up a default select editor with nano. So bin.nano. Okay. Yeah, very good. On that profile, let's see text profile real quick. It's going to tell me. They are a couple more minutes, and I gotta go grab the kids' bags. All right, terminal text editor. So here was the redirect. See, this is where I was messing up. Throughout the series so far, we have only stored text and files using a combination of echo command with the pipe. With the redirect, this isn't an efficient way to handle data when it comes to working with files with multiple lines in the sort. It's got a room dedicated to Vim's a tough one. All right. Introduction to terminal editors. There are a few options that we can use, all with varieties of friendliness and utility. This task is going to introduce you to Nano, but also show you an alternative named Vim. Vim. Some people they'll open Vim and then that's it. They get stuck. They won't know how to leave. Awesomeness of Vim. I like Vim though. It's complicated, but it's Vim's super powerful. You know, it is a wicked complex text editor. A lot complex than a lot of people will give it credit. But that's neither good. All right. Yeah, it's easy. It is easy to get started with Nano to create or edit a file using Nano. We simply use the Nano file and then obviously the file name, replacing the file name with the name of the file that we wish to edit. Nano file. Once we've pressed the enter to execute the Nano code, Nano will launch. We can just begin to start entering or modifying our text. We can navigate each line with up and down arrows, or start a new line using the enter keyboard word. Nano has a few features that are easier to remember and covers the most general things as you would want out of a text editor, such as searching for text, copying and pasting, jumping to a line number, finding out what line number you are on. You can use these features of Nano by pressing the Control key, which is represented by the caret. Okay, so the caret sign on Linux and corresponding letter. For example, to exit, we would want to press the Control X to exit Nano. All right, Vim. Vim is a more advanced text editor, which you're not expected to know all the advanced features. It's helpful to mention it for powering up Linux skills. Oh, I love that. Some of Vim's benefits taking much more time to configure. It includes customization, so you can modify the keyword shortcuts to for your choosing. Syntax hiding, that is one thing that is super powerful about Vim, especially when you're on like a basic server machine and stuff like that. Using Vim can go along. You can go a long way with Vim because of stuff like syntax editing, highlighting, and stuff like that too. Vim works on all terminals where Nano may not be installed. So the original Vim, I believe, I think it's on all disk. No, I don't want to say all. I think I don't want to say that for sure. I just know there is a copy of Vim on most distros of Linux. It is that time that I need to go grab my kiddos for the cookies. So let's do this.
Here we go, guys. Today is the big day. Today is the dream machine build, guys. All right. All right, guys. Here we go. This is the big day. This is the day we all been waiting for. This is right here, the dream machine, guys. So what we're gonna do, I know everything's kind of blocking me right now. I just wanted you guys to kind of see, encompass, everything that's involved with the dream machine. And I know a lot of you computer guys out there, you're seeing a keyboard, monitor, and stuff like that. The reason why I have absolutely everything up here, guys, is because everything had to be purchased for this dream machine to be to come to life. I didn't have a keyboard, I didn't have a monitor, I didn't have any basic computer parts that when most people, I guess, build computers and stuff like that, they can carry over parts over from computer to computer. In this case, my case, starting from scratch, guys. Again, this is going to be my first computer I've actually ever owned. This is going to be my first computer I've actually ever built, and I'm doing it in front of you guys. I'm doing it with you guys. This is all. It's going to be my experience shared with you guys. I'm so excited, guys. I'm so excited. I've been so nervous ever since the Amazon driver dropped this off to me. I've been shaking ever since because this is 2 months in the making right now, guys. Yeah, and it's coming true right now. All dreams have to start somewhere, guys, and this is where mine's gonna start. All right. So, without further ado, we're gonna start cracking into all this, guys. This is a special episode right here because, again, this is what it's all about, guys. We're gonna be building this computer today, the dream machine, in front of you guys. All right. So I'm gonna drop this right down right now, guys. So there we go. Drop this right down here. There's the monitor, guys. We're gonna drop that monitor right down there, get it out of the way. All right, we'll move. Where are we gonna go from here? All right, so we got, yeah, great, good looking box. Whatever. This is our 2 terabyte Seagate Barracuda mechanical drive. Okay, this right here, the Seagate 2 terabyte. This was only $51 off of Amazon, guys. Pretty cheap, not bad. Then we got the Kingston SSD 240 gig. This was super cheap, guys. This was only $39 off of Amazon. Pretty, decent buy. We got the Nakatura 1700. This is a nice quiet fan. I end up getting an additional fan for this. I just don't want to. I don't want to end up hurting any of these big expensive part right here. And let me just move this out of the way so we can kind of see what we got going on right here. So this is the MSI 1660 Super. And I ended up scoring this. This was $282 off of Best Buy. It's not bad. Not a bad price for a 1660 Super. Yeah. You know, we settled on the 450. From what at least I can tell from now, from my inexperience, it should be enough to get me up and running. So that's why we settled on the 450 Go. The AMD Ryzen 5 1600 AF. Yeah, it was only 85 bucks.
All right, I'm back, everybody.
Guys, they're really not bad at all. So last but not least, we got the MSI B450 Tomahawk full ATX motherboard. Couldn't get the Max, guys. I got this off of Amazon, and I got this for, I think it was like 114 bucks.
We are back.
Did you see all of us moving around seat to seat? Oh yeah, they were.
Dying.
I really don't like when other people picking each other.
Yeah. They should. That was cool today.
Good.
Yeah.
Yeah, at least one thing, we played handball.
You guys played handball at school today?
Yeah.
Yeah, how was that?
Good.
How do you play? We used to play, it was called suey when we were kids. And it was a form of handball. It's just a little rough where if you missed your target, everybody would grab the ball and throw it at you until you reached the wall. So that's how we used to play handball. It was called suey.
One thing it's different now.
Huh?
No throwing balls back at each other. Just throw the ball in the net. Teamwork. 2 teams.
There's 2 teams.
Yeah. Red and yellow.
We're playing handball.
Handball. Actually, one thing.
You throw the ball at a wall, and you're supposed to hit a target.
Nah. That was one thing for like the game that I'm playing. It's different.
Is it?
2 goals. Like you have to score like the ball in one of like the opposite teams.
Yeah.
Goal.
That's cool.
And at least one thing you have to have good coordination and teamwork. Cheese touch.
No cheese touch. They got me with the cheese touch again.
And I think you should go back to your streaming. Come on, Jojo.
Thank you, baby.
Get me.
All right, let me get back to my stream here. My fans are waiting for me, Jojo. My fans.
How many people do you have on?
4 million. I got 4 million people watching me right now.
You have 2 people.
Hey, listen, I'm famous.
He's insane.
Oh, grab that guy. Put it behind the thing. There you go. Oh, they dropped off. They didn't. You showed them your face and they left.
And if he says he's cool, he's back. Okay. Stop the cheese touch.
You got the cheese touch.
No.
Buddy.
I'm my fingers crossed.
You're the mega cheese.
No, you're the mega cheese.
You're the mega cheese.
Well, you're cheesy.
You're cheesy.
No, you're cheesy. Cheesy.
You're cheese times a million.
No, you're cheesy and salty.
Yeah.
And peppery.
I'm salty.
That's okay. Imagine being salty. How does it feel?
Alright, let's get back into this. Alright, Vim is a much more advanced text editor. It has more advanced features, it's useful. It's helpful to mention it for powering up your Linux skills. Some of the Vim, so we just talked about this. Customizable syntax highlighting. Here's a little cheat sheet. Tab. This is the room for Vim. So here's a little cheat sheet. It's a nice little cheat sheet too. Ooh. Nice little cheat sheet for Vim. So exiting, this is one of the things that gets people confused a lot about Vim. Right here is actually how to get out of Vim. So you have the :W, which writes and saves. Then your :P. You have a : exclamation point, : Q, not : P, : :q, quit, :q, exclamation point, will quit and unsave. Then you have write, save, and quit all tabs, so that'd be the WQA. Again, it gets into it's a little complex, but once you kind of get like some of the basics down with Vim, it's more powerful. Like you can split screens, you can have, I don't know how many tabs you can have open. I know for sure 4. It might depend on the terminal, but I know for sure you can have 4. You can just like split it into like a split screen. You might even have more for all I know. Cut paste, yeah. So it's got a lot. Again, it just has a lot. It's super feature. Look at it. It just keeps going on. This is just a cheat sheet. I got a whole book on Vim. I actually have it. Where's my book on Vim? Where's my Vim book? There's my Vim book. Here's my book just on Vim. It was written by it. It was written not by the author of Vim, but the author of Vim credited the author of this book, which is the author of this book is Stephen Oculin. Yeah, so it's this thick just to learn how to use Vim. A little complex, but this is the book to buy. It's the official book for Vim right there. It's my Vim book. All right. Create a file using Nano. It'll be fine. So there we go. So we just created a file with Nano. That easy, super easy, super easy. Edit text 3 located in the TryHackMe. What is the flag? So if we come over here to, we're just going to use Nano. We can use cat to spell it out, but it wants us to use Nano. And then we have our flag right there. Text that. Go, complete. Very good, very good. All right, general useful utility. I have one more kiddo I need to grab. All right. All right, downloading files. A pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. We're going to cover the use of wget. This command allows us to download files from the web via HTTP, as you were accessing the file in your browser. We simply need to provide the address of the resource that we wish to download. For example, if we want to download a file named myfile.txt on my machine, assuming I knew the web address, it would look something like this. So the wget HTTP access TryHackMe, yada, and it has the whole entire URL to that particular file that it wants to download. All right, but you need to have that URL, that specific address where that file is located on that server. Okay, even the directories and all things. all those names up there. Just making sure the bus isn't early. Transferring files from your host through pretty much secure copy. So that's SCP, secure copy. Secure copy or SCP is just that, a means of securing copy files. Unlike the regular CP command, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. Working on a model of source and destination. Working on a model of source and destination, CP allows you to copy files and directories from the current system to a remote system, copy files and directories from remote systems to your current. So it allows both ways. Okay. Provided that we know our username, passwords of our users on our current system and on our remote system. So both credentials on both machines, remote and current. For example, let's copy an example file from our machine to a remote machine, which I've neatly laid out in the table below. So the IP address, so the IP address, the user, the file, name of the file on our local machine, name that we wish to store the file on it. So this is just its transferred name. That's what that's saying. Or you could just use the original file's name. So with this information, let's craft our secure copy command, remembering that the format of secure copy is just source and destination. Okay, it's just source and destination. So here we go. So secure copy, so the source file, okay, so the important txt, and now our destination. So we have Ubuntu, we have our user at IP address colon our directory. So it's logging into the home of Ubuntu, and then this is what it's going to be naming that important txt. It's going to be renaming that to transferred txt right there. Hold on a second. Hello. How are you? It is definitely. Okay, hold on. Huh. Good, baby. How are you? I do. I know. I know. Right. I don't feel like it. So. All right, let me. I'm streaming right now. Let me call you right back. Right, I'll be done in a little bit. All right, I love you. Baby. That was me beautiful wife, guys. Excuse you. You want to tell me how she's doing? My lovely wife, I love her. Okay, so to reverse secure copy, it gets into how we're going to reverse that. So if we wanted to download a file off of a server onto our local host, this is how we do it. So we still have our variables, IP address, username. Now what we want is we need to know not only where this document is located, so we need to know the directory where this document is located, the document name itself. So we have the document name, it's document.txt, and then what we are going to name that document once it's transferred over to our local machine. We're going to turn that into note.txt. So the command, so we have secure copy. All right, a little bit different from when we're on our host transferring to another host. This is, we are on a host looking to transfer a file from there over to us. So we have our command, secure copy. Now we have our destination. So it's just a little bit of reverse. So it's destination. So we have our username, IP address, and then the destination of where that document is located. So it's located on the home Ubuntu directory, and then inside that's where our document is, and then we're going to then rename it once it transfers over to us to note.txt. So I get up a couple more minutes, so I gotta grab the last kilo off the bus. All right, serving files from your host. Okay, Ubuntu machines come with a prepackaged, with Python 3. Python helpfully provides a lightweight and easy to use module called HTTP server. This module turns your computer into a quick and easy web server that you can use to serve your own files. Where they can be downloaded by another computer using such as curl or wget. So so the HTTP server, so lightweight Python HTTP server, what it does is it takes the current directory which we're working in, and then it serves it up as a web server. So then, like it says, we can use wget or curl to download particular files from that server. So Python HTTP will serve the files in the directory that you run the command. So you have to be in that directory. You want to run that command inside the directory that you want to serve up. Okay. But this can be changed by providing options that can be found in the command page. Simply, all we need to do is run the -m flag switch here to start the module. In the screenshot below, we are serving directory call. We are serving from the directory called web server, which has a single file named file. So if we come over here and so here's that -m flag right here. Run library modules as a script. Terminate option list. Okay. I got about before I get out there again. All right, now let's use we get to download the file using the computer's IP address. Using the computer's IP address in the file and the name of the file. One flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. This is why I prefer to use the updog. What is updog? What is updog? Updog is replacement for Python simple HTTP server. It allows you to upload and download via HTTP, HTTPS, and you can set ad hoc SSL locations and basic. Ooh. Oh, that's nice. View in browser. Ooh. That looks very useful. All right, let me be right back. I gotta go grab the lasso kit.
Bucks. Yeah, 115 bucks off of Amazon. So all in all, if you take out the Windows, so if you say we don't include the software and we just include all of the hardware for this computer build all together, and that's keyboard, monitor, and everything else minus the actual Windows Pro software, this complete build was $925, guys. I guess if you remove the monitor and the keyboard, that'll bring it down to pretty much like an $800 build. And I'm gonna go, guys. We're gonna start off with the motherboard. We're gonna empty all the contents out of the motherboard box. We're gonna open up the CPU. We'll go from the CPU onto the RAM and so on and so forth. So guys, I'm gonna cut real quick. I'm gonna move the camera so you guys can see what I'm doing, how I'm doing it. So we'll be right back, guys. All right, guys. All right, so we got the motherboard out. Here's the motherboard, guys, right here. What we're gonna start doing now is we're gonna open up our CPU. There is a couple pieces that we're gonna have to take off for now and put aside just so we can get all the installation and all that done. So I'm just gonna move this off to the side. We're gonna open up the CPU. Again, guys, this is the Ryzen 5 1600AF. I'm gonna just slice it. Get the actual cement on it, guys. So, and I'm not gonna touch the back. So here we go, guys. Here's the Wraith cooler right here for you, all right? AMD does send a decent cooler with this. It is real nice. There's always one thing I've always been taught, and that's, use the right tool for the job. Don't use the wrong tool for the wrong job, guys. It makes it makes doing the job you're doing harder.
He said he can't go next,
and you have the potentiality to break things. A triangle there in the corner to help you identify where you're going to be putting that the CPU in the correct position. So all we need to do, guys, to get this ready is we just need to simply.
Now, righty then. Let's get back. Finish up. Cover. Alright, so we took a look at Updog. Updog looks really good. And more advanced yet lightweight web server, but for now, let's stick to using the HTTP. I don't want to forget about Updog. That is really cool. On this. I feel like this mind. Oh, they got it all locked up. All right. All right, so it's just showing us how to the file. On the screenshot above, we can see that we get. All right, so let's try this out. So what do we got on this computer here? So we got just some of this. Now, if we do Usage. Now, if we come here, we don't have to go there, but so we open up another terminal, and here we're in our. This is our root. So if we do a wget on what's the address? Ten, 172, 219. Do what's in the files we have here. Test 3. Got me. It's the right IP address, right? 172, 219. Why is it only showing that? People going ham outside. Everybody's buying outside right now. There it goes. It was on the wrong port, that's why. So there it is, right there. I was just on the wrong port. So there you can access it through the web browser too as well. And we should have our task 3, so we downloaded our task 3 successfully. So here we're you can see it's even giving us all the information. So from 10/10, 219.203, we did a good request. We got 200 code. Yeah. Okay. So there we go. So we downloaded the files. Very good, very good. Ensure that you're connected for the instance. Yep. Now use Python 3 HTTP server module to start the web server in the home directory of the TryHackMe. Yep, we did that. Download the file. So we can do, and then we'll do the, is the flag? Yeah, the flag TXT file. It's just hidden. So if we do the flag TXT file, we can download that next. And we have our flag TXT file right here. And then we can do a cat on our flag, and we have our flag. All right, the flag. All right, great. And download the file, which is what we're running. Yep. Yep. Okay, so let's kill the terminal there. You guys doing all right out there?
Yeah.
What are you doing? Huh?
Just grabbing my phone.
All right. A bit of that. The next one. All right. Processes 101. Pull my hair up. Pulling the last bits of my hair up. This ain't good. All right. Processes are the programs that are running on our machine. They are managed by the kernel, where each processes they are managed by the kernel, where each processes will have an ID associated with it, also known as a, what was that?
Just my backpack.
Chill, Max. Okay.
My backpack.
A PID, process ID. The process ID increments for the order in which the process starts, i.e., the 60th process will have a PID of 60. Okay. Viewing processes, we can use the friendly PS command to provide a list of running processes on our user sessions and some additional information such as status codes, the sessions that is running, how much usage time on the CPU is using, in the name of the actual program or command that is being executed. Note how the screenshot above, the second process has the PS ID of 204, and then the command below it, it then increments at 205. Okay. Oh, I see. So PS, so this is the process ID, 681, let's do PS again. And then there must have been a couple processes in play that had taken place between here and there. So 6 processes happened since we used it again. So, and then look at that. So what is that? About 30? Yeah, about 20 some odd processes has happened since we did it. So there we go. The screen to see the processes run by other users and those that don't run from our sessions, i.e. system processes, we need to provide the aux to the PS command. So let's do the PS aux, and it gives us a list of all the processes here. Quite a long list there. So we have our first process here. Okay, so we have the init, some threading, some workers, some CPUs, all kinds of processes that take place. Let's get down to where we did some of ours. This is just what's running right now. Yeah, that's pretty much what's running right now. And there is our last thing that we ran right there. All right. No, we can see a total of 5 processes. Note how we now have root and keeps on running that other one, even though it's not on there. So LightMD, DM, Procrest, yeah, all kinds of good stuff. All kinds of good stuff. Another very useful command is the top command. Top gives us a real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but we will also refresh. When you use the up and down arrow keys to browse the various rows. Another great command to gain insight into the viewer is the top command. So we do the top, and it'll give us a list of what is going on. Yeah, there we go. PID, process ID number, root, command Python. Yeah, very good. We can see, we can send signals that terminate processes. There are a variety of types of signals that correlate to exactly how cleaning the process is dealt with the kernel. To kill a command, we can use the appropriate name kill command associated with the PID that we wish to kill. To kill process ID 1337, we use kill 1337. Below are some of the signals that we can send to the process we kill. So below are some signals that we can send to the process when it's killed. So the sig term kills the process, but allows it to do some cleanup tasks beforehand. The sig kill kills the process, doesn't allow any cleanup after the fact. Sig stop suspends the process. So there's just some stuff right there. How do processes start? Let us start off by talking about namespaces. The OS uses namespaces to ultimately split up the resources available on the computer, such as CPU, RAM, and priority processors. Think of it as splitting your computer into slices similar to a cake. Processors within the slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security, as it is a way to isolate processes from another. Only those that are in the same namespaces will be able to see each other. We previously talked about process ID, how process ID works, and this is where it comes into play. The process ID of 0 is a process that can be started when the system boots. Process is the system's init on this process is the system init on Ubuntu, such as systemd, which is used to provide a way of managing user processes and sits in between the operating system and the user. For example, once a system boots, its initial systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what is known as a child process of systemd. This means that it will be controlled by systemd, but will run on its own processes. Although sharing the resources is from systemd, to make it easier to understand, to make it easier for us to identify, it looks like this. So,
Hey, Daddy.
right there. Systemd process 1.
Do you know your history
What?
about John Cabot?
Who?
John. His last name is C-A-B-O-T.
Cobalt? I don't know what.
I just want to know what age he died at.
I don't know. Look it up.
No, I did. On my phone and my computer, it won't tell me.
Where is he from?
I think it was England.
What did he do?
Sip.
Said what?
Shit. He wanted to find the closest way to, go to Asia.
Asia from England?
Yeah.
Oh.
To the west. But he went to America.
That's Christopher Columbus, my guy.
Yeah, Christopher Columbus. What age did he die at?
I don't know.
Because I looked it up, it won't give me anything. It'll give me the years. And I already know the years. Like, neither in like the link, it won't tell me what age he died at.
I'll look it up in a minute, okay?
Okay. If you can find something that's close to, yeah.
Okay, we'll look it up. All right, so we've seen that we have our process one, system MD process one. Okay. Getting processes and services to start on boot. Some applications can be started on the boot of the system that we own, for example, web service, database service, or file transfer services. This software is often critical and is often told to start during the boot up of the system by the administrator. In this example, we are going to be telling the Apache web server to be starting Apache manually and then telling the system to launch Apache 2 on boot. Enter the... What machine am I doing this all off from? Am I doing it from the... Enter the use of systemctl. This command allows you to interact with the system ID processes daemons. Continuing on with our example, systemctl is an easy to use command that takes the following format. So systemctl options service. So we can start, stops, and restart services with systemctl. For example, to tell the Apache to start up, we'll use the systemctl start Apache to. I believe this one already has a web server running. That's mine. You right here. Just copy that. For example, to tell the Apache to start, we'll use the systemctl start Apache. Seems simple enough, right? Same if we want to stop the Apache server, we'll just replace with the option of start instead of that. We can do 4 options with systemctl: start, stop, enable, disable. An introduction to background and foreground in Linux. Processes can run in 2 states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo or things of that sort, will run in the foreground of the terminal, as it is only command provided that hasn't been told to run in the background. Echo is a great example, as the output of echo will return to you in the foreground, but it wouldn't in the background. Take the screenshot for the example. Okay. Here we're running the echo TryHackMe where the expected output will return to us like it has started. But after adding the AND operator to the command, we instead of just given the ID of the echo process rather than the actual output. Oh, okay. As it is running in the background. This is great for commands such as copying files, because it means that we can run the command in the background and continue on with whatever further commands we wish to execute without having to wait for the file to copy to first. Okay. We can do the exact same thing when executing things like scripts. Rather than relying on the AND operator, we can use the Control-Z on the keyboard. Use Control-Z on our keyboard to background a process. Oh, okay. It is also an effective way of pausing the execution of the script command. Okay. The script will keep on repeating. This will keep on moving to stop until I stop or suspend the process by using Control-Z, as indicated with the So right there. Now our terminal is no longer filled with messages until we foreground it, which we will discuss below. Foregrounding a process. Okay. Now that we have a process running in the background, for example, our script, background sh, which can be confirmed by using the px-aux. Yep. All right. We can backpedal and bring the process back to the foreground to interact with it. With our process in the background, using either Control-Z or the AND operator, we can use the FG to bring this back to the focus, like below, where we can see the FG command is being used to bring the background process back into the use of the terminal, where the output of the script is now returning back to us. So it just brings it back. All right, README, I read me. All right, if we were to launch a process, where the previous ID was 300, what would the ID of this process be? It'd be 301. If we wanted to cleanly kill a process, what is the signal? So that is the SIG. Where is it? The SIG term. Locate the process that is running on the deployed instance. What is the flag given? There it is. Right. What command would we use to stop a services? My service. So spell. What command would we use to start the same service on the boot up system? What command would we use to start the same service on the boot up? Woo! It's getting hot. I really need to get some AC. All right. What are you trying to? Where are you confusing me? That's what I got. Huh? System, CTL. What command would we use to start and stop the same services on the boot up? What command would we use to start the same service on the boot up of the system? Why am I getting confused with that? Let's see if it's this. No. No?
This has got me perplexed.
Or I'm just so stinking hot I can't think anymore. That might be part of it. Alright. Some applications can be started on the boot of the system that we own, for example, web service database, yada 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 yada. For example, entering the use system of this command allows you to interact with the system ID process. Continue. For example, system CTL.
Hey, Daddy,
You.
can you give me up some water?
In a minute, buddy, okay?
Okay.
I have no idea what this question is even asking. This is done. Ah! I hate it when I ask these stupid questions. Any stupid questions. What command would we use to start the same service on the boot up of the system? I wonder what it's asking. Man, it is hot. I'm just getting pissed. One or the other. Probably getting pissed a little bit. What command would we use to start the same service on the boot up of the system? I have no idea what it's trying to say. It's not system D. It's not system D. Seriously, I only have like 30 days. It is hot though. I can't even think right now. Woo! I need to get an AC in here. Pronto! I can't even sit in here. It's so hot right now. I have no idea what command it wants me to find. It's not Apache. I don't know what else it wants me to do. Very confused. What command? this works. That is fucking stupid. Oh man, wow. That was dumb. That was extremely dumb. Is my service even running on this? Like, how would I even know that? Yeah, I don't get that. I don't get why that answer is enable my service. Like, I don't. That's ridiculous, by the way. If you hear me try hack me, that was ridiculous. What command would you use to bring a previously background process to the foreground? That would be use the FG. Oh my goodness, it is always so noisy. What are you doing now? Oh, I can't get it. Maybe this was a bad time, huh? No, we don't. Let me finish these up. All right, maintaining your system automation. That is effing annoying, by the way. Put on my headphones. Light that shit out. All right, maintaining your system automation. Users may want to schedule a certain action or a task to take place after the system has booted. Take, for example, running commands, backing up files, or launching your favorite program, such as Spotify or Google. We're going to be talking about the cron process, but more specifically, how we can interact with it using with the use of the cron tabs. Cron tabs is one of the processes that that is started during the boot, which is responsible for facilitating and maintaining cron jobs. So, man, context. All right, cron. A daemon to execute scheduled commands. Cron is started automatically from etc initd on entering multiple user run levels. So we have some options. Stay in the foreground. I'm getting annoyed. This is why I definitely gotta get the AC in my window. I'm not dealing with this. Especially it's too stinking hot too. All right, cron tabs is a simple. A cron tab is a simple simply a special file which with formatting that recognizes by the cron process to execute each line step by step. Cron tabs require 6 specific values.
Hey, Daddy.
What?
Just to let you know, JoJo's gonna take me outside.
No, he's
I'm
not.
going to George.
No, he's not.
He's out there.
Okay, you're gonna have to wait. Go clean your face too. What's all over your face? It's like they want to tell me what to do. All right. We have minute, hour, day, month, day of the week, and the command that will be executed. Let's use the example of backing up a file. You may wish to back up the documents in 12 hours using the following. Oh, yeah. Oh, that's a good plan. Love it. All right. Sorry, guys. I didn't hear that. Hopefully, you don't hear it too much. An interesting feature of Crontab is that these also support the wildcard, the asterisk. If we do not wish to provide a value for a specific field, i.e., we do not care the month, day, or year, this is executed only, that is executed every 12 hours. Gonna lose it. Now it's gotta be sweltering hot in here now that I have my window closed, but hey, gotta be listening to that. I swear he's right outside my window right now, doing it on purpose. An interesting feature of Crontab is that there is also supported by the wildcard or the asterisk. If you do not wish to provide a value for a specific field, i.e., we don't care the month, date, or the year is being executed, only that is executed every 12 hours. We simply just place it in asterisk. Oh, okay, so those fields are required. Oh my goodness, he is legitimately just going ham out there with his weed whacker, with his 1-inch lawn. I swear he's doing his whole lawn with the weed whacker. Annoying it is. Alright, this can be confusing to begin with, which is why there are some great resources such as Crontab Generator. This allows you Crontab Gen. Oh, okay, so dude, I'm gonna lose it in a second. I really am. He is going ham on it. It's I swear, as long as this big, as long as this big, he's still doing it. I don't get what he's doing. Besides just doing it to annoy me at this point. This allows you to use a friendly application to generate your formatting as well as the cron site guru. So we have 2. Okay, that's cool. And then this one, the cron gen generator. Did he stop yet? Oh, thank goodness he stopped. Oh, I think I gotta take it. So, we have 0. Is there not an option? Every 6 hours. Every day, every month. /home. Alright, so that's cool. So we have a little, it generates our little cron job generator for us right there. Similar to what it had generated over here for its own backup here. Very cool, very cool. Let me throw that in the anyways. There's a useful one right there. There's some just there's some useful links you guys can take a look at right there for y'all. Oh, and here's this one. Here's Updog as well. You guys can take a look at all those cool little links right there. All right. Ensure you are connected to the deployed instance and looking at the cron tabs. When will cron tabs deploy on? When will the cron tab? Oh, okay. Cron tabs can be edited using the cron tabs -E, where you can select the editor such as now to edit the cron tabs. So let's go back on this instance here. When will the cron tab instance deploy? Ensure that you are connected to the deployed instance and looking at the cron tabs. It's not giving me anything. I don't. Man, I hate when things don't. Cron tabs can be editable.
Hey, Daddy.
What? Ah, you're on the stream?
Mhm.
That's cool.
Watching it from the Chrome.
Thanks, buddy. Oh! Is the... What is the FIFA? What is a FIFA? It's the wife. Oh, it's the wife! The shaving. Hello, the wife. Welcome to the stream. You know what's crazy? JoJo's on the stream too right now. Say hello to JoJo. Hello. My beautiful wife. You saying hello? JoJo says hello too, by the way. Hey, make sure you mute that so it doesn't double feedback in here, Joe, okay? Thanks, buddy. He's laughing. My 1 million people are in my stream right now.
You're not there yet.
All right. When will the cron tabs on the deployed instance run? I don't get what I'm running wrong. Yeah, it doesn't. there is no, see what I'm saying? Like, that's ridiculous. I got stuck in Vim for a second. Alright, so obviously it's not there. So I guess we have to take a look at this. Maxi Poo, little Max, cause I said you listen to. Oh, kicked my whole thing. Mad, not Max. The Maxi Poo. Hello, it's Joe. Oh, shoot. How are you today? Good. Oh, shoot. It's today. Yeah, appointments today, isn't it? Yep, let me hop on it right now. All right, everybody, I gotta jump off the stream. I forgot I had an appointment today, so I will see you all later. Be good, stay safe, and stay cool. All right, guys. We'll talk to you all later.